Hi, my name is Summer Vaught. I'm the math director for Arkansas Ames and a former BC calculus teacher. So today we're going to talk about how to review for the AP exam, specifically in terms of series and error in series for both alternating series and positive term series. So I'm going to go ahead and share my screen with you all and we can get started. So I've written down some things that you guys need to know for the AP exam in terms of error. Error comes up quite a bit. I think in terms of all the free response I looked at over the last 10 or 11 years, it probably came up 7 or 8 times. It's generally just one piece, maybe part C or part D at the end of the question. But it's something that really kind of tricks students up, but it's not too difficult, especially for alternating series error. So let's start with that one. So if your series alternates in sign, so it's got to go positive, negative, etc. after the first couple terms. So if you have 2 positive terms at the beginning, maybe, and then every other term alternates, that's fine. So I gave you guys this definition. I know it says theorem 1.2, but basically it says that we have a convergent alternating series. And sometimes it's just convergent when absolute. So when it says convergent, because we're looking at power series, we're just going to assume it's convergent when absolute value x or x minus a is less than r. So we probably just have one interval, like for a power series, where it's going to converge. So that's fine. And also the terms decrease, which generally isn't an issue either. Then the error in the nth partial sum is no larger than the absolute value of, they say, a sub n plus 1. And so I kind of broke that down for y'all because that's a more complicated definition. The error, and I like to write this out for students because they ask error in several different ways on free response questions. So you need to know how to recognize it. So basically you have this polynomial and you're going to use it to approximate the value of your function f, whatever the polynomial is defined to be, at some value, and I called it b. So your polynomial at b minus the actual function at b is going to be the error, right? The difference between your approximation and the actual function. So sometimes you're asked it in this form, where it's that difference in absolute value symbols. Sometimes they say the error, they say it lots of different ways. So your error is basically less than or equal to the next term at x equal b. And that's generally how I write it. If it's alternating, it's less than or equal to the next term at x equal to whatever value. So say you're using a 4th degree polynomial to approximate at 1, then the error would be less than the 5th term of your polynomial at x equal 1. So you'll see on free response questions, a lot of times they'll ask you to say, write 4 terms or like a 4th degree, and then in one section of the problem, and then in the next, they'll ask you to use 3 terms or a 3rd degree to approximate. And they were nice enough to make you write that 4th degree up there, and then you'll use that for error. But we'll do some examples. I'll show you. Now, if your series doesn't alternate in sign, this can be a tricky one. And I only found one instance where it came up on a free response in the last 10 or 12 years. And I have that example here for you. We're going to do later. But if it doesn't alternate in sign, what you end up having to do is you have to, it's kind of the next term. But what we want it to be is, because this is an inequality, we want this kind of idea that the error is going to be as big as that term could be. And so we're actually going to end up finding the maximum of the n plus 1th derivative. That's, if you're using a 4th degree polynomial to approximate, then you would find the maximum of the 5th derivative on the interval between where you're centered and where you're approximating. And this could also go a comma x. It depends on which direction you're going. Doesn't matter. So you're going to find that maximum. There's a few ways to do this. So if you have a calculator, which you generally never do on question 6, you could actually, and sometimes you'll find textbook problems that want you to do this, where they want you to actually graph the function. Look, it's going to be absolute value of the function. So if it's negative, think about that. Graph the absolute value of your fifth derivative and figure out which is bigger at, say, a or at x. And then that's going to be your maximum. Generally, it's such a small interval, you wouldn't ever have a turn. So it's always just going to be one of the endpoints. I don't think I've ever done a problem where it wasn't when you're doing it that way. So you have that. That's kind of the most complicated way to find that maximum. The next way would be if your derivative is actually bounded, like sine or cosine. Those are the nice ones. So if your fifth derivative is sine, then its maximum is just, you're going to automatically use 1 because that's what it's bounded. The example we have, they actually gave us a picture of the graph of the fifth derivative. And the only reason you need it in the entire question is to find that maximum. So we'll look at that one. And then it's just going to be basically the next term. So if I'm using a fourth degree, I wrote over that, sorry, to approximate, then I would find the maximum of the fifth derivative. So that could be a graph that I'm looking at. It could be sine or cosine, so it'd be 1, so forth. And then I'm going to divide that by, I'm using 4 to approximate. So 4 plus 1 would be 5 factorial. And then multiply by x minus a to the fifth. In this case, I use 0 and 1. So that would multiply by 1 to the fifth. So I will show you the work. You'll understand more when I come to the example later. But I'm pretty sure we're going to start with alternating series error. So this question was from 2012. So we have this series given to us. We actually use this problem in all 3 of the videos. I have a video on power series where we're kind of looking at like intervals and radius of convergence. And then there's another video on manipulating series where you want to, say, differentiate, integrate, so forth. So they tell us that we have this function g, and we're going to evaluate g at 1/2. And that is an alternating series whose term decreased in absolute value to 0. So they've basically given you the conditions that you need for that alternating series error in the question. And I've seen this come up more in recent years where they're really specific about you guys realizing you need to use alternating series error. So pay close attention. And I'll also give you guys some more tips and others. So they say the approximation for g of 1/2 using the first 2 non-zero terms of this series is 17 over 120. Show that this approximation differs from g of 1/2 by less than 1 over 200. So you have to realize that they're asking you for error. And notice they never use the word error in this question. They also never use that absolute value expression I showed you on the previous page. So when they say the approximation, which is first 2 non-zero terms, that would be p sub 3 of 1/2, differs from, and so that would be subtract g of 1/2, right, by less than 1 over 200. So when I write it like this, and since it's a difference and kind of like a distance, I'll put absolute values. This now is our error. So they basically say when they want to show that the approximation differs from the actual function, that's error. And so basically in this question, they want us to show that the error is less than 1 over 200. So I got to do some work now. So they want me, they tell me that I'm going to use the first 2 non-zero terms. So that's those 2 terms right there, x and then x cubed. So I need to use the next term. So I'm just going to write here. They've already told me that it alternates, but I'm just going to write, and this may be the stat teacher in me, but I'm going to kind of write what I'm doing on the page. So I'm doing alternating series error. And so I'm going to state that my error is going to be less than or equal to the absolute value. And I'm just going to write this in words of the next term at x equal 1/2, right? That kind of just guides me. I generally write this on all my alternating series problems, just so I know, hey, and I could not even say next term, maybe I'd say third term. That would be, I don't want to mess that up. I'm just going to leave it as next term. So I take a look. The first two non-zero terms, like I said, is x and x cubed. So my next term is x to the 5th over 7. And so I just take that 1/2, I plug it in for x. And then I'm going to say that this, I could then say that, no, this is going to be less than 1/200. Sorry. But 2 to the 5th is 32. You can figure that out. So I know that 3 times 7 is 21. So I know that when I write this thing as like 1/32 times 7, I can definitely see that that's going to be less than 1/200. You don't actually have to do that math there. And I mean, honestly, you could get away with just this right here, but in my mind, I actually like to see just to check my answer that, oh yeah, 32 times 7, definitely bigger than 200. So then that's going to be less than. So really, you don't need a lot of work in these problems because they've kind of done a lot for you by telling you that you've met the conditions needed to use alternating series error. All right, so let's take a look at another example. All right, here is the one that we're going to use Lagrange. And also, this is from 2011. So at the top of the page, they've given us this graph for the absolute value of the 5th derivative. Like, okay, that's random, but maybe I'll use it somewhere. So then they say, so I didn't include the whole problem here. So we're actually going to need the graph, the series for f, which I have included. I just copied from the solution from College Board. If you want to know about the other parts of this problem, check out the power series and manipulating series videos. So then they say, let P sub 4 of x be the 4th degree Taylor polynomial for f about x equals 0. Using the information from the graph of the absolute value of f. So since they tell me they want me to use information of this graph, and I don't think I have a general term, but I noticed that my first two are positive, my next one's negative. I don't have any other information. So I'm not necessarily sure that this is a total alternating series. They also didn't give me that information in the problem. So I'm going to not assume it's alternating and think, okay, can I find the maximum of the 5th derivative on my interval from, and then you want to think it's where I'm centered, which is 0, to what I'm approximating, which is 1/4. So can I find the maximum of, I'll write this also, the 5th derivative, x on that interval. And I can actually, because I have a graph of the 5th derivative. This is 1/4 right there, if I can draw a straight line. And they definitely took, I know it's not easy to read here. I'm thinking that's maybe 35. Wait, that's 20, maybe 32. I'm pretty sure they took lots of different values, probably anything between, I don't know, 30 and 40 or something. They definitely are going to count you off because you couldn't read the graph properly. So they're going to give you a big range for what values they need. So I'm going to call that 35. So I'm just going to say it's approximately equal to 35. And then I'm going to write down that I'm using Lagrange error. Right. And then I'm going to say my error is going to be less than or equal to. You could write out the whole statement about max, but since I've written this already on my paper, I'm just going to start off by saying, okay, the maximum of the next derivative, which is 35, over n plus 1 factorial. N is 4. So I'm going to write here n is equal to 4, right? So I'll go ahead and do one more step. 4 plus n plus 1 factorial, and then x minus a. A is 0, right? So that's just going to be x. X is 1/4 to the n plus 1, and that would be 5. I guess I could write 4 plus 1, but anyway. All right, so now I'm going to simplify a little because I do need to somehow figure out this thing's less than 30,000. So I'm going to see how much math I can do. I've got 35 on the top. On the bottom, 5 factorial I do know is 120 times 4 to the 5th. Well, Lord. Numbers always get me. I can do all the calculus. So I can divide both those by 5. Let's see. 35 over 120, that's pretty close to 1/4. So basically 1 over 4 to the 6. I'm going to say, I don't like that question as much because it's really hard to do that math without making mistakes and also without a calculator. So I will go ahead, pull my calculator out because I'm the teacher. And do that math. But if you're confident in your abilities to do Lagrange error, then you should know I did that right, and that's definitely less than 1 over 3,000. All right, so I have that 1 over 3. My answer is 0.00028, and 1 over 3,000 is 0.00033. So yes, so I'm going to say here that this is 0.00028. It's giving me ease on my calculator, which is less than 0.00033. Check. You wouldn't have the ability to do that, sorry, on your AP exam, but you should be fairly certain of your methods to know that that's going to be less than 1 over 3,000. Or, excuse me, pardon me, sorry. Or you could do some fun, multiplication on the side of your paper and do it by hand. Okay, so that's our one Lagrange error problem. So I know that it seemed maybe when your teacher taught that, or maybe they didn't teach it, it can seem a little scary, but it very rarely comes up on free response. Or if it does, they are not going to have you fight to figure out what the maximum of that next derivative is. They're either going to provide it for you or going to provide you a graph or give you something easy like sine or cosine. All right, so let's try one more alternating series error. So here, this is a really fun problem actually, but here we had to integrate to get the answer for G, right? Or to find F, sorry. Here is, actually, I apologize. This should say G here. Here is G of X, our approximation. So the Taylor series for about G evaluated at 1, so A is 0 and X is 1, is an alternating series with individual terms that decrease to 0. Excuse me again, I'm sorry. So they say use the 3rd degree Taylor polynomial for G. So I'm going to go ahead and look up here at what I have. That's my 3rd degree, right? To estimate the value of G of 1. And then explain why the estimate differs from the actual value. So that is the phrase that we want that will lead us, that says they want error from G of 1 by less than 1 over 6 factorial. So I need to make sure I answer both of these questions. So use the 3rd degree Taylor polynomial for G to estimate the value of G of 1. So even if you totally forgot how to do error, realize that that's going to hopefully be a point in this question, at least 1 point, and you don't want to miss points. So make sure you're reading it very carefully. So g of 1 is approximately equal to, I'm going to use the third degree. So 1 minus 1/2 plus 1 cubed over 4 factorial is 24. 24 times 3, 48, 70, 48, 24, 72. My math skills can be bad sometimes. And honestly, I wouldn't combine these and get one term because you don't actually need that for the next part of the problem. I will do my calculator here and get an answer so you'll have one. And I got 37 over 72. But you definitely, I wouldn't do that because we're not going to use g of 1 anywhere else in this question. It's part D. It's the last part. So just leave it that way. 37 over 72. Okay. So next I'm going to do, they asked me to estimate or explain why this estimate differs from the actual value by less than 1 over 6 factorial. So I'm going to do alternating series error. Right, because it tells me it alternating series right there. And I'm going to say the error is going to be less than or equal to the absolute value of the next term at x equal to 1, right? Yeah. Okay, so my next term is x to the 5th over 5 times 6 factorial. So this is going to be less than or equal to the absolute value of, and I'm going to include the negative, but it's absolute value, negative 1 over 5, negative 1 to the 5th for 5 times 6 factorial. And they were really nice on the numbers here because 5 times 6, 1 over 5 times 6 factorial is definitely less than 1 over 6 factorial. And there's no, I don't have to do any simple math there. So that's check. So once again, this was a really nice, straightforward question. And even if you're afraid in part C that you didn't get the answer to G correct, which happens, then just use what you did in G. And if you do it correctly in part D, you'll get full points on D. So don't forget about that. They don't double ding you on questions, because they had already, anyway, taken off points for part C if you missed it. So I would like you guys to do this next problem, and next 2 problems, I'm going to post solutions along with it. And then hopefully you can do these on your own and maybe work with your teacher on them. And she'll share the solutions for you so you can check your work. I really appreciate you guys coming in to learn about error. And I wish you so much luck on your BC Calculus exam. If you have any questions for me, you are welcome to email me. My email is slvaught1@ualr.edu. And thanks again. I hope you'll have a great day.